right, everyone. Thank you. So today I will present some of the work that we've been doing in Critical TechWorks on pricing. And so for the agenda of this session, we'll go through from wholesale to direct sales, also the domain data science strategy, then a deep dive on the future sales model when we go throughout our implementation and some results, then future steps, and show you off our team members. All right. So if you think about when you go to a dealership, right? The dealer basically tries to sell you the car with a price that they think are profitable for them and just for you, right? But if you go to a second dealer, right, you might find a different price there. So why is that? Because dealers usually buy out the cars made by the manufacturer, and then after, from the distribution, it reach out to their warehouses, right? So for the manufacturer, the cars are already sold, right? It's called the wholesale. And the objective of the dealers is flowing out their supply to customers, right? Given that they will receive a benefit, a compensation at the end of the day, because they will reach the target sales, right? So essentially, the dealers will set up the pricing with a lot of discounts. A customer can also look for different dealers to get also a great price. But still, dealers also are very important on managing the customer relationship and also administer their inventory, right? But it's a problem, right? Because you can get a price point for a vehicle and your friend can get the same vehicle with a different price point. And where's the premium on that, right? So for this reason, we will change a little bit how the business model will be. So from wholesale, traditional wholesale, we'll change to future direct sales model, where we still have the manufacturers building out the cars, distributing along across different European markets. But then we'll have the dealers only having some discussion about the vehicle, recommendations or recommending to the clients, but the prices will be fixed, right? So in our case, our objective is to establish the best price for each vehicle, so that the customer always looks into the category of the vehicles and sees always the same price. So in Critical TechWorks, my team belongs to this unit, the Data Legion, and we have a lot of different products, teams, approaches to reach this ambition. The right car with the right price at the right place and time. And there's a lot of topics here, like governance, processes, also building sales reporting tools, also optimizing volume planning, pricing, which is where I'm working on, stock management, having less transit on the vehicles, less stops, and flowing out the inventories. Also, vehicle configuration, where we also try to predict what the customers really want, so then we can build upfront the vehicles and send it out, reducing the time of delivery. And then some funnel analytics, where we go from marketing to the customer demand and needs and preferences, and then demand sensing across the European markets. So let's go to the future sales model. As you can see, we are building different components. We have data engineers, data scientists, data analysts, and also front-end developers. And we begin with having all different KPIs from all different data sources to our basically provider account, where we can assess and consume all these different KPI data. And then after that, we have a component of different analytics, like elasticity, prediction model, optimization model, where we try to bring the optimal price suggestion. And then we have a KPI system where we try to calculate, derive from different KPIs to have a new formula and new insights. And right after, we collect all these KPIs into different categories, different dashboards, so that pricing managers have a lot more information to also establish a great price. And then this will be displayed on a user-facing and a governance layer, where pricing managers will set up their scenarios, and then a pricing manager lead per market will approve or disapprove their suggestions. Right. So today we're going to focus on this a little bit, elasticity prediction model. And I'll start off by referring to the price elasticity of demand. If you can think about this metric here, basically tries to measure the responsiveness of quantity demanded of a good, of a service, to a change in its price. Meaning that, for instance, if we have a lower than 1 elasticity for a small amount of price change, we can have a really jump, downlift on the volume, right? Or there are certain vehicles that are inelastic, so any change on price doesn't really affect the volume output, right? So in absolute values here, the higher absolute elasticity, the higher is the volume response to the price changes, right? So this is the metric we're trying to calculate. So we, as a young team, starting from late 2022, we started with a simple Remax model, where we can also include exogenous variables. And why is that? Because we have, it's a model that has independence and linearity assumptions. It is able to also construct confidential intervals for the predictions, and simple, interpretable, and explicit target distribution also. But also there's some cons where there's strong independence assumptions from the variables and linear dependency limitations. And some of the results that we got here were for the high volume sales market. We got the mean correct, but the variance super underestimated. And also for lower volume markets here. And you can see also here the data showing off what should be the actual standard deviation and the predicted one. And also the R-square, very low volume, so probably saying that the mean it's a better model than the actual Remax model estimation, right? So we changed to a more complex deep learning approach, because we also thought about of having more KPIs involved. We could say that there's macroeconomic indicators. There's also market share for the registrations of every brand in Europe. There's also volume, of course. There's the properties of the vehicle as categories. And because of that high volume data, we chose this model, and assuming that we can use the elasticity formula here, and then solving it as the volume target, where B is the baseline forecast. Okay, you can think about the baseline as the intrinsic demand that the model tries to calculate in a set point, but also understands or tries to understand the distribution among the interactions of the KPIs. Okay, so we have or there is an existing phi correlation with between future ordered intake volumes and past ordered intake volume. So if we try to forecast future scenarios based on the current price, we'll already see how it will settle the volume, right? And it's also considered as an autoregressive model, right? So we can incorporate past volume for that. So we started out like this baseline estimator, and we are already inserting and normalizing our numerical features. And for the categories, of course, we are applying an embedding layer to have everything numerical, and then feed the baseline estimator. And also, a separate component is this elasticity, where we apply just a simple neural network, where we feed out also these embeddings to them. But these are all being processed internally on a loss function, where it tries to catch a symbiosis between the demand and also the elasticity for the price that we are inputting, right? So for the elasticity component, we apply also this formula to guardrail the minimum and the maximum elasticity, and the minimum maximum is brought out by previous projects that previously is applied, and also verified by the pricing managers as suitable for each vehicle, essentially. But the model doesn't predict every type of vehicle. There are new vehicles coming in, new properties of the vehicle, like body type changes, even the engine, like we are transitioning more and more to the EV space. So because of that, there are some cascading logic being applied to try to fetch some volume or some other KPIs from, for instance, predecessors, vehicle predecessors, also from other markets, and increasing the granularity a little bit and applying the median value to get the features. But there's also the embeddings inference as another logic, where we can assume, like from the embeddings, maybe with a specific property of the vehicle being unique, we all cut it off and apply more general, more common properties from comparable vehicles, essentially. So, for instance, you can find the same market, horsepower, and fuel type, and this will infer from the vehicle that we don't know to a proper or kind of similar elasticity from that, right? But then there's data issues, right? Because if we look at it in a time series manner, some vehicles have some good patterns for the model to be trained, but then there are others where you face like this kind of volume, which is very, very residual, I'll say, or even complete gaps, time gaps. So in order to have a more cut-off measurement of how many months you will want to have for these time series, we came up with the value of 36 months, when also observing how much longer the months will take to then drop out all the information from every feature or every subgroup. So we established this 36 months. And then results. We have results and we need to find a reference if the results are following the correct assumptions, and also based on the opinion of the business owners, right? They are the experts. They've been working on this for years and years, right? So for instance, the hypothesis is, on average, models have lower absolute elasticities at the end of their life cycle. You can think about like elasticities are towards to 0 for older generational models, right? Because on average, models have the life cycle of 4 years, more or less 3 to 4 years. And we saw that happening more or less, like having higher magnitude elasticity at the early stage, but then lesser at the older stage, right? And then another one, on average, high-tier models have lower absolute elasticities. So we can see a transition from lower-tier vehicles to higher-tier vehicles, that the distributions more or less starts increasing. I would consider in the mid-tier doesn't happen, but maybe because there is a high variance of vehicles and properties and so on. But overall, it shifts to this kind of elasticity values towards to 0, right? And also, if you think about like customers prioritize brand reputation and also having a high-tier model, like the client that is most likely rich doesn't think about having a discount of 100 or 1,000 euros, right? So that's why we think about as low elasticities for these vehicles. And then you can see that common body types compared to exotic body types, they are adjusting to the correct elasticity values overall. Lastly, on average, markets with higher EVs and FEVs share have lower absolute elasticities. This is according to also very low options for the customer compared to internal combustion engine vehicles, right? So that's why price differentiations doesn't affect volume sales, and especially for high volume markets, right? So for instance, in the Nordics, it's common knowledge that there's a lot of vehicle fleet of EVs in those places, so people are buying, they have more monetary power to do that, and so on. And these are the main results here compared to high volume markets and also low volume markets. You see a trend, a positive trend according to, I'm not showing here because the types of series vehicles, but you can imagine that higher tier vehicles have less and less elasticity overall, even on a high and low volumes. Also, you can see it here on the regression, a series level, and then market level. And then also, we try to find out if the overall elasticity distribution was generalized enough to any type of vehicles. And we can also see by the life cycle stages, the same properties, and then on average, also the elasticities for each life cycle. And yeah, future steps. We're just beginning on this. This little component took around 7 months with a lot of quality issues on the data, a lot of processing, a lot of infrastructure being built, communication with different departments and so on. And we are aiming for now a quality gateway component, explainability component for the KPIs and also the model to trace back to why this kind of elasticity is being brought up or suggested. KPI to source traceability component, also very important. not just for us, but also to the pricing managers and business owners. A machine learning model experimentation component. Drifts, because markets shift, right? There's a lot of component, a lot of different variations going on the macro indicators. Some optimization on our infrastructure, and then individual and global optimizers to allocate every different domain that we have around pricing and stock and so on. And then lastly, generative AI. We are starting aiming for that for several use cases around our domain. And yeah, this is the team, quite big one. We started by 4 in the beginning of this journey, and then there's a lot more here and a lot more to come. And thank you.
For looming here like a phantom menace, but I was torn between listening to you and having the questions, because there's a few popular ones. Yeah. By far the most popular, how do you account for competition prices in your forecasting model? Because evil never sleeps and neither does competition.
Yeah, you can imagine that competition is, or gathering data, competition data is very tricky, right? Because it's considered as web scraping. And not all companies are able to do it because of antitrust laws. There are other ways to understand the market share, which is registrations of plates, right, for brands and type of vehicle. And we have access to that. This is publicly available for companies, if I recall. But this is kind of a way to understand how competition is going, right? And we can infer of a certain tier pricing for these vehicles. Yeah, I think.
Okay, clear. Thank you. The second one, do you account for the price being influenced by the historical demand? Yeah, I would imagine that's kind of naturally baked in the Serimax component.
Yeah, exactly. On the Serimax and the DPR, it always accounts to past volumes. And it's very good to have that, because it has seasonality component, trend components, and also other variables that can mix on these past volumes. Yeah.
The questions just keep on coming. How much data was enough to train the DeepL model? Did you not have problems with overfitting or underfitting, probably, for that matter as well?
We have problems. Like I don't recall the amount of data. It's in the, I would say it's in the thousands, not the millions. And I understand deep learning, it's all about big data on the millions side. But still, you can think about that it didn't underfit or overfit. It did in the beginning, but the solution that we found was enriching more of the data, of our data assets, right? To have more the life cycle of the vehicle, normalizing better the data, adjusting, fine-tuning the model also. So there were different approaches, different scenarios, even including, I didn't show off that, expressiveness stats of like synthesizing data and seeing how the model reacts to that.
Synthetic data?
Yeah. But I didn't show the results because it was kind of
proprietary shaky stuff, probably. Yeah, I can imagine. Okay. Oh yeah, that one is close to my heart as well. How do you predict the future values for the exogenous variables?
For the, sorry?
Exogenous variables. Oh, sorry.
Good question. We haven't done it, but it should be some of our scope to have like some multi-models on trying to find out how the KPIs are evolving, right? Even on the drifts component, we are assuming that markets will change. Like GDP is always changing, and we'll see from the KPI levels also. But
okay. Yeah. And a quick last one, how do you calculate the prediction intervals?
The prediction intervals,
because you mentioned them, I believe, at the beginning.
Yeah. So the confidence intervals, it's like trying to find the residuals between the set points, right? We will, in that case, in the Serimax, we were assuming that there was some sort of normal distribution. So we have a 95%
parametric
interval, right? So it's parametric.